So in the real world, linear programming is used all the time. And jobs that work with production and profit often use linear programming on a large scale every day. And their goal is to make the most money that they can and produce products in the most efficient manner. And what we're going to practice today is how do we write these equations so that eventually we can take this idea and move it on to put it all together here at the end of the week. But the key on this is to organize. And that might be using colors, charts, or tables to help organize the variables and the numbers. So here's our first example. We've got Super Bats Incorporated manufactures two types of wooden baseball bats, the Homer Hitter and the Big Timber. The Homer Hitter takes 8 hours to trim and turn on the lathe and 2 hours to finish. Each Homer Hitter sold makes a profit of $17. The Big Timber takes 5 hours to trim and turn on the lathe and 5 hours to finish, and its profit is $29. The total time available for trimming and for lathing, so that's trimming and turning on the lathe, is 80 hours. The total available time for finishing is 50 hours. And the first thing that we want to set up here is, what are our variables and what do they represent? Well, eventually what we're going to be doing is we're going to be graphing these problems. So consequently, I'm going to use X and Y because we're going to have to graph. And what we have is, we have the Homer Hitter is one kind of bat. And our other kind of bat is the Big Timber. Now, if for some reason you said that the Homer Hitter was Y and the Big Timber was X, that's okay. And that's the point of listing that, so that a person that's reading your information can interpret it that way. The second part of this says, write the objective equation. So we didn't use this wording yesterday, but the objective equation is going to be the f of x and y. And what we have to do then is, it says we are trying to find our profit. So we want to go back and look and see, do we have any equation that's indicating profit up here? Again, the objective quantity equation is going to have f of x and y in it. So we need to go back into a problem, and we need to look for money that we're going to be making. And in our first bullet, it says each Homer Hitter sold makes a profit of $17. Well, we said that the Homer Hitter is X, so this is going to be 17X. And then we want to look and see, what's the profit that we're going to make when we sell the Big Timber? Well, the Big Timber is going to make a profit of $29. And we are representing Big Timber with the letter Y. One other thing that I want to just circle here, and maybe you do too, the objective quantity equation is dealing with our profit. How much money are we going to make? So now that leads us to our third part of this problem. We want to write the system of inequalities that describes the constraints. Yesterday we practiced graphing the inequalities, and today we want to write the inequalities that eventually we're going to be graphing. So when we go back and look at the problem, what's happening is there's two things happening in the problem. The Homer Hitter takes 8 hours to trim and turn and 2 hours to finish. The Big Timber takes 5 hours to trim and turn and 5 hours to finish. There's two things happening in this problem. We're going to have an inequality where we're only dealing with trim and turn. And then we're going to have an inequality that deals with finishing. So we want to pick out what's happening in the problem. We want to identify that fact so that we can write our inequalities. So we go back to our original problem once again. The Homer hitter takes 8 hours to trim and turn. Again, Homer hitter is going to be the X. 8 hours to trim and turn. As we look back at the problem, though, now what we want to know is how many hours does it take to trim and turn for the big timber? Well, the big timber takes 5 hours to trim and turn. And now, to finish this inequality, what we have to ask ourselves is, how much time do we have? How many hours do we have to trim and turn? Well, that last bullet says the total time available for trimming and lathing. I forgot the word trim and turn on the lathe, is 80 hours. We want to put this symbol less than or equal to in there, 80. And remember, this isn't over a day necessarily. This could be over a month's time. So don't get caught up in the fact that there's not 80 hours in a day. We can spend less than or equal to 80, but we don't want to give any more time than that to the trimming and turning. Well, the finishing. Now, that's the other thing that's happening in this problem. The finishing of a home hitter takes 2 hours. And again, Homer hitter is an X. How many hours does it take to finish the big timber? Well, it takes 5 hours to finish the big timber. We have to keep going back and reading this problem over and over again. How much time can we give to the finishing? Well, the last bullet says the total available time for finishing is 50 hours. And again, we can spend less than 50, but we're not going to spend any more than. We can spend equal to, but we can't spend more than. But there actually are 2 more inequalities in this problem, and that goes to the box that's down at the bottom of your page. It's up a little bit higher on mine. But what it says is, it says, while not explicitly stated in the problem, it is understood that you can't make a negative amount of bats. With that being said, what 2 inequalities should we add to our list from above? Well, in general, what happens is that if we are going to make a profit, we need to assume that we're going to make some Homer hitters and we're going to make some big timbers. So what we need to add here, oh, by the way, these will almost always be 2 additional inequalities in every linear programming problem you encounter. So it's almost a given that you are going to have in our problem here, X is greater than or equal to 0. We're going to make some Homer hitters, and Y is greater than or equal to 0. We're going to make some big timbers. Now, that's the first problem that you've seen. You may or may not understand that, and we have plenty of examples to work through today to hopefully get you going in the right direction. So let's turn our page. An automobile manufacturer makes cars and trucks in a factory that is divided up into 2 different shops. The first shop, which does the basic assembly, needs 5 worker days per truck and 2 worker days per car. The second shop, which does the finishing touches, needs 3 worker days for both cars and trucks. The first shop has 180 worker days available per week, and the second shop has 135 worker days available. The profit per car is $500, and the profit per truck is $700. And the first thing that we want to do is we want to set up what are we working with. And it's actually that last bullet that I think might be the most helpful. Because what it says is, it says the profit per car. So let's say that X is going to be the cars. And the profit per truck is what we're going to let Y equal. Again, maybe you wrote X equals truck and Y equals cars. We're allowed to do that. Your inequalities will be slightly different from mine, but will work out the same in the end. Part B. Write the objective quantity equation. The objective quantity is this f of x comma y that we dealt with yesterday when we were finding the maximum and the minimum values in our problems. Well, we go back here and we look, and again, it's that last bullet here in the problem that's the most helpful. It says the profit per car is $500, and we said the cars we're going to call X. And the profit per truck is $700, and we said that we would call the trucks Y. Now that we've got those parts identified, what we want to go back and look at is, what are the 2 things happening in this problem? Well, we go back to that very first bullet. It says the first shop, which does the basic assembly. Basic assembly. That's one of the things that's happening in this problem. The second shop does the finishing. And those are where our 2 inequalities are going to come from. So we want an inequality that just deals with basic assembly. We want an inequality that just deals with finishing. The first shop, which does the basic assembly, needs 5 worker days per truck. Remember that truck is Y, so it's going to be 5Y, because that's the trucks. But it only needs 2 worker days for the car. Remember, X is the cars. And how many worker days do we have available for the basic assembly on the first shop? Well, it's in the third bullet, and it says the first shop has 180 worker days available. That's our basic assembly from our first shop. Well, the second shop does the finishing touches. So that's going to be our next inequality. It says it needs 3 worker days for both cars and trucks. So 3 for the cars, 3 for the trucks. How many worker days do we have available? We've got 135 in that third bullet there. 135. Now, 2 more inequalities we need to write down. Again, that goes back to our box that we were dealing with on the front page. And what that says is that we need to assume that we're gonna make some cars, and we are gonna make some trucks. And those two inequalities in general will be on every single one of our problems. Now hopefully it's starting to make a little bit of sense as we work through. The hard part is we need to be able to pick out the information from our problems. And on the first two examples, we've had kind of a list that we can work with. But on our third one here, we just left it in problem form. And it says, Stitches Inc. can make at most 30 jean jackets and 20 leather jackets in a week. It takes a worker 10 hours to make a jean jacket and 20 hours to make a leather jacket. And the total number of hours by all of the employees can be no more than 500 hours per week. The profit on a jean jacket is $20 and the profit on a leather jacket is $50. And what we're going to do is we're going to go through the same way that we have, but now we're going to have to pick out the information from the actual problem. Well, our two variables here. We've got jean jackets and we have leather jackets. And eventually what we're going to be doing is we're going to be graphing these, which is why I prefer to use X and Y every single time. The objective quantity equation has to do with profit. So this is going to be f of x comma y. And we look back in the problem and we ask ourselves, well, how much profit are we going to make on a jean jacket? Well, the very last sentence, the profit on a jean jacket is $20. How much profit are we going to make on a leather jacket? Well, when the profit on a leather jacket is $50. And what we can do, for some people this works and some people it doesn't work. But sometimes what people say is, oh, I use that. I don't need that anymore. I'm going to cross it out. And that doesn't matter. It doesn't matter to me if you do that or not, but that might be a helpful technique. Because that does get rid of a little bit of information so that we don't get it confused in the rest. But this one is slightly different from the past. It says, so now we need to write our system of inequalities. And this one is a little bit different from the last one. And it goes back to that very first sentence. It says, Stitches Incorporated can make at most 30 jean jackets. So our first inequality that we're going to write is jean jackets being X. We're limited. We can only make 30 jean jackets or less. That's why I have the less than or equal to symbol in there. And we're limited on making the leather jackets as well. We can only make 20 or less leather jackets. Now, that of course is assuming that we are going to make some jean jackets and we are going to make some leather jackets. We can't make money if we don't make them. So there's those two inequalities that are almost always in the problem. So we just took care of, in our problem, the 30 and the 20. So we only have a little bit more left here. There's not necessarily two things happening in this problem. Now, based on everything that we crossed out, it says it takes a worker 10 hours to make a jean jacket. And it takes a worker 20 hours to make a leather jacket. And as we look back in the problem, how much time do we have to make the jackets in the first place? Well, the total number of hours by all employees can be no more than 500 hours per week. And there's our setup of our problem. Problem number 4. We've got a chart here to organize a little bit of the information, but we've got the words as well. And we've got TV Electronics makes console and widescreen televisions. The equipment in the factory allows for manufacturing at most 450 console televisions and 200 widescreen televisions in 1 month. The chart below shows the cost of making each type of television as well as the profit for each. During the month of November, the company can spend $360,000 to make these televisions. So remember, these are big companies here that are making these kinds of products. And when we start, we can set up, and hopefully it's pretty clear that we're going to have widescreen, which I'll use X to represent. And, sorry, I want consoles to be the X. Console, because that's the first one listed, is usually how I do it. And then Y is the widescreen. Our second part, write the objective equation. That's our f of x and y. And the objective quantity equation deals with the profit. So when we look at the profit here, what we see is that the console, it's in the chart, the console makes $125. And we're representing console with the X. The widescreen from the chart, profit per unit, says that we make 200 for each widescreen that we sell. And we're representing widescreen with the Ys. So now we've got that, and again, if it works for you, you've dealt with that. So you can cross it out. We've taken care of that information. So we go back into the problem. It says the equipment in the factory allows for us to make at most 450 console televisions. So again, when we set this up, we're limited. We can make less than 450, but that's it. We can make a total of 450. We can't make 451. We also have some limitations on the wide screen. So if we go back up here in our problem, it says the equipment in the factory allows for manufacturing 450 consoles and 200 widescreen. And again, we can go back in our problem and we can cross that information off because we dealt with that. So we only have one more part that we need to deal with here, and that says the cost per unit. That's coming from the chart. And our cost per unit says that it takes $600 to make a console. And it takes $900 to make a widescreen. But there's a sentence underneath the chart. During the month of November, the company can spend $360,000 to make these televisions. So that's going to be our less than or equal to the $360,000. Well, lastly, and I almost forgot, but hopefully you didn't, we need to put in here the fact that we need to assume that we're going to make some console TVs and that we are going to make some widescreen TVs so that we can actually make some money on these TVs. The last one now, and hopefully you're kind of getting the hang of things. A farmer has asked you for advice on the best strategy for planting wheat and corn on her 500-acre farm. To make it through harvest time, each acre of wheat she plants will require 1 person day of labor and other expenses of $20. Each acre of corn she plants will require 5 person days of labor and expenses of $30. The farmer has $11,400 and 1,480 person days of labor available, and she expects to make a profit of $90 per acre of wheat and $120 per acre of corn. So we look up here, and what are our two variables? Well, what do we have first? Wheat and corn. And the objective quantity equation, that's dealing with our profit. F of X and Y. And it says she expects to make a profit of $90 per acre of wheat, and wheat's represented by X, and $120 per acre of corn. And we've just taken care of this last part. And again, you don't have to cross it out. If that works for you, that's something that you could use. And on this particular problem, again, we're looking, do we have two things happening? And we actually do have two things happening. And what it says is that we've got each acre of wheat she requires 1 person day of labor. So we're going to have an inequality that has to do with labor. And other expenses. So it's kind of weird here, but the other inequality is going to be the other expenses. So to make it through harvest time, each acre of wheat she plants requires 1 person day of labor, and each acre of corn, and by the way, I should put that 1x, each acre of corn requires 5 person days of labor. And how many labor days do we have? We've got 1,480 person days. We can do the same kind of thing. Now we're looking at the other expenses. Well, it takes 1 person day of labor for the wheat and other expenses of $20. So 20x, that's for the wheat. And then for the corn, it takes 5 person days of labor and expenses of $30. And then we look and see, how much do we have available? We have $11,400 available. And don't forget that if we are going to make any money, we need to assume that we're going to plant some corn and we're going to plant some wheat. Sorry, plant some wheat and plant some corn. X is the wheat and Y is the corn.